So what we're going to do now is talk about how to deal with this, okay? This is the calculus part of the course, all right? This is where the fundamental ideas of calculus are most important. So we're about to spend a lot of time right now on basically this, the concepts and calculus of kinematics, okay? Because what we want to think about is how do we know now we're all good at going this way, right? Oh, if I have a position curve, I just think about the slope. Here, I just think about the slope. What about going the other way? What if you had acceleration and you wanted velocity? Right, then you got to go backwards. So that's calculus. So let's take a minute and talk about what calculus is. Okay, calculus is a complicated way of describing walking from A to B. Okay, that is all it is. All these special symbols they show, it's all confusing. What is this? What's going on? It's literally just walking from A to B. If I have my 2-meter stick here, like this, and I'm here at the beginning, and I walk, and I end up here, all right? It's calculus. I'm going to demonstrate calculus for you here. So here is 0. Here I'm at A. Just going to walk. B, calculus. I just did calculus. That's all it is, okay? So let's show you why that's all it is. It's because, let's answer the question, how far did I go? Did I go? All it is. How far did I go? There's 2 ways to know how far I went. And the second. All right. How far did I go? Anybody just shout out how far I went? 2 meters. How do you know I went 2 meters? Because it's a 2-meter stick. How do you know it's a 2-meter stick? If you came up here and looked at it, how would you know it's a 2-meter stick? It's what? It's got marks on it. And this one says 0. And this one says 2 meters. So how do you know it's a 2-meter stick? If that says 0 and that says 2 meters, how do you know it's a 2-meter stick? Yes. The first way is it's just the positions, XAB minus XA. That's the first way. Is I know where I started, I know where I ended, and I know I walked from one to the other, so it's just the difference. So I missed these, it wasn't beeping, it's on nighttime mode or something. So where's G sine theta? We'll worry about that later. That was just part of the story. And does T x squared apply regardless of the steepness of the ramp? Yes. And we'll get into, those are good questions for later. Okay, so one way to know how far I walked is just how far did I walk? The 2 positions, the beginning position and the end position. What's the second way? What if you didn't have the ruler without any marks on it? How else could you know how far I walked? How fast I went and what time, right? We could multiply how fast I went by how long I went, right? Are those going to be the same thing? Yeah. And that's all calculus is, right? It's just saying you can have the rate, or you can multiply the rate times the interval and get the distance back. I mean, that's all it is. Now, why is calculus like a 3-semester course? Okay, if that's all it is, why? And let me show you why. How many of you here have your dad or some other family member has ever embarrassed you in public? Okay, good. Cool. I embarrass my kids in public all the time simply by existing. But here's something my dad used to do. When you're walking and he gets excited about something, he'd do this. He'd walk and he'd go like this. That's like his thing, right? That's his move. Okay, we're walking, we're going to dinner, we're going to go to dinner, and we're going to get dessert. Yes. And he goes like that. Okay? So here in this, we imply that this velocity is constant. But what if you have like the embarrassing dad, and if you were to plot the position of that weird walk, so now we're back up to here for a minute. So dad was walking up like this, and suddenly he went backwards for a minute. Right? But he didn't get back past the origin, so he's staying positive x, negative, then he goes back forward again. Right? Okay. So slightly weird walk, but that's what it would look like. But now you can't just multiply v times delta t because the v kept changing. Walking forward, walking backward, walking forward, moving your arms like that, you know, doesn't work. So you need another way. instead of just multiplying the two, if v varies in time or space or whatever, if v varies, you break it into small dt's, into small delta t's, and add. All right, sorry about that. And add them up. That's literally all calculus is. It's saying you can take a derivative, and you can take it by an integral and add it up, and you'll get the difference back. Literally all it is. So we write that this way. Instead of saying it's just v times delta t, when, say, v is constant, we say it's this symbol, the function v times dt. Okay, what is that symbol? The integral symbol. And does it scare you? Does it kind of get a thing in the pit of your stomach a little bit? Okay, I'm going to make it more friendly. Are you ready? The integral symbols. Anybody know what I'm going to show you? I'm going to show you what it really is. It is here. This is integral symbol. It's in the Constitution. That's how important it is. We, the people of the United States, in order to form a more perfect union, establish justice and something, ensure domestic tranquility, provide found common defense, promote general welfare, and this is Schoolhouse Rock. You weren't there in the 70s. And secure the blessings. Wait, what is this? B-L-E, what the hell is that? Blessings? So when they used to write two S's, the big S was big and fancy, right? That's what the integral sign, it's an S, it means sum, right? Blessings of liberty to ourselves and our posterity, ordain and establish this Constitution of the United States of America. And there's Congress right there. Article 1, Section 1. Congress, C-O-N-G-R-E-S-S. They would get excited when they wrote two S's, and that's all the integral symbol is. It's a big S from like the 1700s, okay? So don't be afraid of the integral symbol. It's not a big deal, okay? And watch Schoolhouse Rock if you want to memorize the Constitution. It's the best way, okay? Now you got to put something on it though, right? So we can't say, are we going to integrate my dad's walk for his entire day? No. Only on the part that we care about. So that's what these are, from T1 to T2. So we're literally summing up the multiplication of the velocity at this time times that dt from T1 to D2. And that will also get you how far you're going. Okay? See, so if that's so simple, how does that still take 3 semesters? Right? And the answer is how to take this mathematically is a little bit of work. There's all the tricks you learn for polynomials and sines and cosines and exponents and products of those things and the chain rule, and that goes on for a while. But even that should only be 1 semester. When it gets complicated is when you get into higher dimensions and you use vectors, okay? When you use 3-dimensional vectors, then there's 3 kinds of derivatives. Very complicated. You know, the divergence and the curl and the gradient, and they each have their own fundamental theorem like this, and then they all get related to each other, and it's a gigantic mess. That's 3rd semester. That's like vector calc, okay? But all 3 of every fundamental theorem of calculus, divergence theorem, Stokes theorem, they're all basically just saying this. Right? The difference in some function is just the integral of the derivative of the function times the delta t. That's all anything in calculus is. Okay? So don't be afraid of calculus.